So good day, everyone. My name is Dave Robertson. I'm a community engagement manager at the Valsera company. One of the things I really like doing is talking to researchers like yourselves. So I'm going to encourage you now and later on to come to our virtual office hours, which are held twice a week, and we'll send you the link for that. So let's begin first by understanding the benefits of migrating to the cloud. The key being recovered data cannot be moved off of the NHLBI clouds per the data use agreement. This is similar to other studies. So we're going to motivate the cloud in this slide right here. So migrating to the cloud can also significantly reduce your cloud cost, and it can also accelerate science. So the old solution, as you may know, your institution may have a high performance computing cluster. Unfortunately, in that case, data is duplicated, and there's a lot of indirect costs, such as the electricity to run it, et cetera, et cetera. There's always duplicate physical copies of data around the world for each institution. It also could require a comfortability with coding on the command line. And there's different types of security at different institutions. So the cloud offers a single core infrastructure with a single physical copy of the data, and it saves time and infrastructure costs. There's also a low barrier of entry in some cases by providing a low-code solution if you find that will be helpful, and there's additional security certifications. So let's put down some objectives for this short presentation. Number one, we want to understand how cloud credits are used. Number two, we want to learn about all the helpful features that are available to researchers for managing your credits. And finally, I hope that you can become efficient at budgeting for your research projects, including estimates in grant proposals or requesting cloud credits from NHLBI. In addition, you can do things like feasibility studies and task cost modeling. So next, we'll dive into the different types of costs, and it's quite simple. And I will pause here and say that my understanding of the Recover project, it's not going to be a tremendous amount of cost upfront, so not to worry. So there are two main types of costs. There's cost for data storage, which includes storing sort of new inputs, storing your outputs, your intermediate files, and data transfer. Data transfer is also known as egress. One of the egress will not be allowed, which is downloading the data. The cloud providers charge for downloading the data. You can't do that. But there may be cases where you need to move from one cloud provider to another. So that's be something to aware of. There may be egress charges there. Just FYI, researchers don't incur storage costs for any hosted data sets. So that includes the recovered data sets, as well as other major population-based studies such as TopMed. The second way is computational costs. So this is cost for running analysis. There's really two main types of computational costs. There are interactive analysis, where I think a lot of the researchers here will start with, which is running, an RStudio notebook, a Jupyter notebook, a SAS Studio environment. But in addition, you can run large-scale jobs, which we call tasks, on Biodata Catalyst powered by 7Bridges. Terra, a lot of this is also applicable to Terra. So with this understanding, let's explore how the cloud credits can be used efficiently. So, breaking it down into storage and computation. For storage, one of the first things I recommend to people is to only run major analysis tasks just in time. So this may not be applicable to you, but if you're running a genome-wide association study, sometimes I see researchers convert all their whole genome VCFs to an R format called GDS immediately, and then sort of work on fitting an old model, et cetera, et cetera. You want to convert, every time you convert, you're going to be having what we call derived data, which will be a new physical copy, and you'll be paying for storage. So you want to minimize that. Be mindful of the data's original location. So create a project that is located where the data lives. Now, hosted data such as Recover or TopMed has been mirrored across multiple cloud environments, so you don't really have to worry about this. And of course, use the hosted data wherever possible. So when we're talking about computation, I want us to do a few things. First, a lot of the times there'll be estimates in the public apps gallery apps. You can trust those, but verify. Start small. Start with a small chromosome or small data set, and just to see if it's behaving as you think it will be. Always make use of the spot market. Spot market, you may have not heard this term before. It's simply reduced cost of machines, like they're kind of on sale. Use those wherever possible. Always use the most efficient software and make sure that the software is utilizing compute resources efficiently. The public apps gallery will do these automatically, so they're designed to run in parallel. But if you're if you're coding your own script, you may not realize that you'll be saving a lot of time and cloud credits by making your job run in parallel. So efficient workflow design, of course, is another crucial aspect. Part of the ways to increase cloud credit efficiency is to reuse the intermediate files. I'll demonstrate one of the features or one of the settings. Intermediate files are, let's say you have a multi-step workflow. Between step 1 and 2, you don't want to have any outputs back to your project, but you're going to feed those into step 2, and then you'll have your final output. So these intermediate files can be saved for as short as 1 hour or up to 5 days, just in case you want to rerun your analysis and change some of the downstream settings. Always use appropriate instance types. This is especially relevant for RStudio or JupyterLab. You don't want to pay for more compute than you're actually using. And of course, make sure you have multi-threading and batching turned on if that's appropriate. For Data Studio, always select an appropriate instance. If you need to run with the graphical processing units, those will be more expensive. Definitely use those if you're doing machine learning. But if you're not, use sort of like the default, which I'll tell you what that is in a moment. Always have the suspend timer on. So the default is 30 minutes. I generally increase it to 60 minutes or so, but this is a period of inactivity. After your timer runs out, it'll go ahead and save your results and stop your machine so you're not overcharged. Finally, let's go ahead and talk about porting repeated tasks to CWL workflows. A lot of researchers will get comfortable in their normal environments, RStudio, SAS Studio, or JupyterLab. If you can port those repeated tasks to CWL, you'll be able to utilize lower cost compute. So how do you estimate these? And this is a really sort of back of the napkin type thing. But what you really need to do for storage, for example, is you need to know the size of your data and how long you want to store it. So the typical storage cost is 2.1 cents per gigabyte per month. This is prorated by the second, and of course, the NIH strides will further reduce that cost for you, but this is a good sort of back of the napkin calculator. So you just need to say, how long do I need to store this data? Once again, Recover, I don't think this is really going to make much of an impact, but for TopMed, where they're using whole genome data, this can make a big impact. Use benchmarking information for when you're looking at the workflow costs. Test your data in small, medium, and large files. So if we're talking about chromosomes, chromosome 1, chromosome 12, chromosome 22, just to see if you can model that cost. Is it increasing in a linear fashion or a geometric fashion? And of course, a typical cost for a notebook is about 30 cents per hour. This will be, about 16 gigabytes per RAM and sort of multi CPU. This should be really great for prototyping and for doing a lot of analysis, but it can go upward and even a little bit below that if you want. So to further help with cost estimation, let's talk about some useful platform features. These are specific to biodata catalyst powered by 7 bridges. So apps, of course, will have benchmarking. Some of the apps actually now have a cloud cost estimator where you can use the file picker to select the files you want to use, and it will give you an estimate for how much that particular task will cost. After you're after running a task, so don't run all your analysis at one time. Sort of run it in small batches. Monitor the cost and see if the cost is what you expected, and is it really using all the compute resources? And there's a way to check for that in the task metrics. When you're making a project, choose the appropriate cloud provider. So on Biodata Catalyst powered by 7 bridges, you can choose Amazon Web Services, Azure, or Google Cloud Platform. In some cases, this may not make that big of a difference, and it'll be sort of transparent to you. But if you know you're collaborating with someone at the Broad, for example, that has a lot of data that's stored on Google Cloud Platform bucket, you want to make sure you choose a project that's located on GCP Cloud Provider. For billing groups, look at the detailed credit usage, and also set a spending cap. If you have the spending cap, it will not allow you to go over, and it will not allow you to run any more analysis. So to fund your computational resources, understanding your different payment options is crucial. I think number one here is going to make a big impact for the Recover project. So for new non-commercial users, you can request $500 in pilot credits. This is going to go a long way in the Recover project. For other sort of machine learning, large imaging projects or whole genome sequencing projects, that may only get you to pass the pilot testing, and then of course you can look at other funding options. You can include cloud costs in your grants, and if you have funding available, you can either prepay with the purchase order or pay as you go. There's various payment options available. So lastly, let's look at how we can support you. So we have all these options, which we will send out to you, of course. There's lots of materials. If you haven't already, please join the Biodata Catalyst community. You can contact the help desk. Attend office hours. About 7 bridges has them Tuesdays and Thursdays. Subscribe to the YouTube channel and rewatch these videos, and keep attending events like this and asking questions. So right now I'm going to show you a practical demonstration of some of the features inside of a project that on 7 bridges. And I know we're over, but it should just take a few more minutes. So I'm in my web browser here, and I'm already logged on to Biodata Catalyst powered by 7 bridges. And I made a project called Cloud Cost Demonstration, and I invited Amber and Emily. Just, if you want to be invited to this simple project, just send me your user ID. So I have some tasks for us to do. I want us to do these one by one. So the first thing is check settings for the cloud provider. So let's see what, you identify this when you make the project, but if you want to see what cloud this is operating on, you go to settings. You can see I made this project today, and it's operating on Amazon US East 1 region. Okay, let's also look at, I made some notes for us. Let's look at the billing group details. So on 7 bridges, you can belong to multiple billing groups, as I do. So keep your funds separated, Recover, TopMed, whatever projects you're working on. If you need to view the billing group details, just click there. And so this is the billing group we use for all our trainings and demonstrations. So it's over 4 or 5 years. So it's getting up there. But of course, I think we do need to trim down the storage, because if you notice, the storage cost is higher than the analysis cost. And I see this a lot. You need to make sure that intermediate files are being where appropriate. It breaks down the analysis charges into tasks, Data Studio, which is the RStudio, SAS Studio, Jupyter Lab. SAS does require additional license fee, and it'll populate there. You can then further look at each project that you have associated and every time you spend credits if you want to. Okay, so let's look at some benchmarking in our project apps. So I added one app from the public apps gallery, and this is for doing the Genesis Genome-Wide Association study. If you click on the app, it gives you a nice description, and in many cases, it will give you some benchmarking. So this is the one of the more extensive ones. Now, you know, no matter what, always test it on your own data with a small data set, with small, medium, and large. That'll give you the most accurate. But here, they're they're benchmarking based anywhere from 2.5 thousand samples, whole genome samples, up to 56,000 samples. A lot of it's dependent on the relationship matrix. Is it dense or is it sparse? But this will give you an idea of how much to budget for. And so let's go back to our notes here. So I want you to understand task metrics. So this is very powerful, especially if you're benchmarking your own analyses. When you run a pilot task, it'll save the information. So this isn't saved forever. And we see the inputs I used, the settings I used, and the outputs that it generated. It shows us the price. So this cost $1.09. If I click on this question mark next to $1.09, it shows that the compute machines was 91 cents, the additional task disk was 18 cents, and the data transfer was 0. This should always be 0. You never want to move or download the data if you can avoid it. But we can drill down even further. If you click on View Stats and Logs, it'll actually show you that it's doing a lot of each one of these horizontal lines represent a single job. So it's doing things in parallel. So I like to see these things stack up. We know that it's being very efficient. So you're saving time, and in many cases, you're saving your cloud credits as well. So you want to sort of drill down and see if it's using this efficiently. You can also click on instance metrics and check the RAM and the amount of CPU. But like I said, for a project like Recover, you may not need to go this deep at all. All right, so we looked at task metrics. Oh, so this is most likely where you'll start. You'll want to launch RStudio or another interactive analysis and choose the appropriate level of compute. So let's go to Data Studio. Went a little over, guys. So I have one running now, but I'll show you how to make a new one really fast. Create new analysis. You can choose between JupyterLab, RStudio, or SAS Studio. OHIF viewer is another type of image viewer, but you can choose those 3 main environments, give your analysis a name. So for RStudio, for example, you can pick the environment. If you want to work with picture, there's a few different picture environments here. There's a machine learning environment. So you pick your environment. Most importantly, choose an instance. The default is really good. It's quite powerful enough, and this will be 34 cents per hour. But you can scale up or scale down from there. So if I wanted something a little bit more powerful, this would be $1.53 per hour. Choose the appropriate amount of sort of scratch storage and keep the suspend time on. So that we have accomplished all our sort of tasks that I wanted us to do.